What's up, everyone? It's Mr. Walker coming to you again with our notes for the day. Last time, we reviewed a little bit about similarity with right triangles. Today, we are finally starting trigonometry. I hope the voice changer isn't too off-putting. I saw it on my video editor and wanted to try it. Alrighty, folks, let's get it started from the top. From our last set of notes, we established 3 ratios that we can make with our right triangles. These ratios are made up of the sides of our triangle when we look at them from our reference angle, theta. First, we have the hypotenuse, h, the side that does not touch our right angle. Then we have the opposite side, o, the one that does not touch our angle, theta. Then we have our adjacent side, a, the side that touches theta but is not the hypotenuse. Now, with these sides in mind, there are 3 ratios we are going to work with for trigonometry. First, we have the opposite over hypotenuse ratio, or what we call sine. Next, we have the adjacent over the hypotenuse ratio, aka cosine. Finally, we have the opposite over adjacent ratio, which we call tangent. With these ratios in mind, let's flesh it out some more with this right triangle ABC. The sine ratio is the length of opposite side, BC, over length of hypotenuse, AB. The cosine ratio is length of adjacent side, AC, over length of hypotenuse, AB. Finally, the tangent ratio is length of opposite side, BC, over length of adjacent side, AC. To help with remembering these ratios, we use a mnemonic device to simplify it and set up our ratios. First, we have SOH to represent sine, with the S representing sine and O over the H for the sides. Next, we have CAH with the C representing cosine and A over the H for the sides. Then we have the TOA with the T representing tangent and O over the A for the sides. Okay, so hopefully that wasn't too fast now. Feel free to go back and pause the video to finish writing anything you missed. I'll slow down for this next part so you can get used to the work for our examples. You are definitely going to need a calculator for this part. I will warn you ahead of time that you need to keep track of the different calculations you are going to get throughout this. Alright, let's get some examples going. Below we got triangle DEF, and we want to use the sides on it to find our ratios. They want us to write each of these as both a fraction and a decimal. Example A asks us for the tangent of F. This means we need to look at this triangle from the perspective of angle F, down in the bottom right. Looking at it from here means that our opposite side is DE and our adjacent side is EF. Now that we know our side, let's plug our numbers into the ratio. Tangent is opposite over adjacent, so with our sides that takes 12 as our numerator and 5 as the denominator. Next, they want a fraction and a decimal, so we divide and get 2.4. Next, we have example B, which has us switching perspectives over to angle D. From this angle, side EF is the opposite side and DE is your adjacent. We're looking for cosine, which is adjacent over hypotenuse. That makes our fraction here 12 over 13. As a fraction, this is about 0.9231. Next, we have example C, and we are using the same perspective from angle D. Here we are looking for the sine of D, so that makes our ratio opposite over hypotenuse. Our ratio is set up as 5 over 13, and as a decimal it's 0.3846. Last but not least, we have example D, which brings us back to the perspective of angle F. Here we are looking for the sine again, but of F, sine is opposite over hypotenuse, so our opposite side is 12 here and the hypotenuse is 13. Then as a decimal it is 0.9231. Hopefully you might have noticed that the answer for B and D happen to match up. This isn't a coincidence because we are using the same sides in both of those ratios. So you will see that some of the ratios happen to match going forward.
Alright folks, hopefully that wasn't too jarring. I'm back and let's get into this. Alright, so I'm going to let you know right now, this part of the notes cannot be done without a calculator. Absolutely cannot be done without a calculator. So you're going to need to make sure that you got one. If you're using your cell phone, it's going to be a little rougher on you. You're going to most likely need one of these that we got over here. So let's jump into it. All right. First things first, before we even jump into the actual questions, new things are showing up on each of our triangles. You might have noticed that we suddenly have an angle on each of these. These angles are the reference angles that we use for our different trig ratios. Now, not only are they going to be helping us figure out what sides we're working with, we also got to go through and use them in the calculator. So let's pull up the calculator. Let's show you what the buttons are that we are going to be using in particular. All right, let me get over here. All right, cool. All right, these buttons are sine, cosine, and tangent. You've never really used these before this class, so I won't fault you for not knowing what they are. What we're going to be needing to do is inside of this parenthesis for sine, we put the angle that we are seeing inside of our triangle. Now, it may not actually be sine, it could be cosine, it could be tangent. It depends on what sides they give you that you're looking for. So, I'm going to walk you through a couple of these so that hopefully it makes more sense. All right, first off, let's look at all our triangles here. We got 1, 2, 3, 4, 5, 6. First thing you want to do is, like any good mathematician, is start to labeling some stuff. So, first off, A, we want to label the stuff that we got here. We got our angle 36. Now, what is this side x to 36? Since this is not touching 36, this means that x is our opposite side. I'm going to mark that as just O right now because writing opposite is a lot with this mouse. So x is our opposite side. Now, 20, since it doesn't touch the right angle, that is our hypotenuse. Okay, now let's get to B. We're going to label the stuff over here. You see that we have the side that's touching our reference angle. That is our adjacent. I'm just going to write A. Okay, then the side that's not touching it, 10, that's going to be our opposite side. Over on C, we got our angle here. One of our sides is touching it, and it's not the hypotenuse. It is the adjacent. So we're going to mark that as an A. Up top over here with 14, this is our hypotenuse again. Hypotenuse is generally easier for you to notice. Okay, so over on D, we also got our hypotenuse again. Over here, 2, since it's not touching our reference angle, that makes 2 our opposite side. Next, we got E. 49 is our angle. We got 2 sides here. One of them's touching it, and it's not the hypotenuse. It's the adjacent side. Then we got 14. This side is not touching our reference angle, which makes it O. Then we got 72. One side's touching it. That is our adjacent side. And then up top, that's not touching the right angle. That's our hypotenuse. Now, based off of the size they give you, you know which trig ratio we're going to be using, okay? So let's write these up real quick. We got sine, which is opposite over hypotenuse. That's so from earlier. Then we got cosine, which is adjacent over hypotenuse. Then we got tangent, which is opposite over adjacent. Let me actually make this an A. Boom. There we go. All right. So based off of the sides you get, you know which trig ratio you're going to be messing with. So first one we got, A, has our opposite and hypotenuse. This means that we are going to be using the sine ratio. So starting off with that, you want to first make up your ratio. Your ratio is with x and 20. So x is up top, 20 is on the bottom. Now, 36 is going to be going with our sine, so it'll help us calculate it. So our equation looks like this. The sine of 36 equals x over 20. Now, I put this 1 down here because whenever we see an equation like this, we're going to have to do a little bit of cross multiplication. So X is going to be multiplied times our 1 down there. Sine of 36 is times the 20. So you got X equaling sine of 36 times 20. Let's whip out our calculator. Let's get into it. All right. So yeah, the sine of 36, we're going to close this up, and then we're multiplying it times 20. Hit and enter. We get this right here, I think. Oop, I got to actually go through and fix my calculator up. All right. One thing I forgot to say it earlier. If you do see a answer like the one I just got, which was negative this is wrong. We're dealing with a triangle. You're not going to have any negative sides. That doesn't make sense. Okay? So, in order to make sure that we don't deal with this, we got to go and mess around in the mode menu. So, hit the mode menu. You want to come down to about the third option where you see the word radian right now. I want you to move over to the right where it says degree and press enter. Okay? From here, this will actually give us the math that we're looking for. Radians is going to be used a little later on in this unit, but right now we're just focusing on degrees because we're dealing with some degree angle inside of the triangle. All right, backing out of here, let's take a look at the new answer. Our original one was negative. That wasn't what we wanted. In this degree mode, we actually get the side that we are looking for, which is going to be 11.755700505. Luckily for us, the directions say round to the nearest tenth. So to the nearest tenth, this is 11.8. So, saw a little bit of a pitfall there. Please make sure that when you start off this, you're setting up your little ratio like how we did. Then when you need to get into here, if you see a negative answer like that, you don't want that. Remember, this is like a distance that we're looking at in the calculator. Because of that, we got to make sure that it makes sense for what we are going to be seeing. So we should be seeing some sort of positive number. All right, let's jump into the next one. Okay. Next one here, we got our adjacent side. We got our opposite side. Adjacent and opposite means we're messing around with tangent. So tangent is going to be equal to our 10 over x. Still got our fraction equaling another fraction. We still got to cross multiply to solve this. So 10 times 1. And then we got x times 25. Now, because of this, we have to do an extra step. So this is going to be x and the tangent of 25. Actually, let me write that over on the other side. Running out of space. Killing it. Boom. All right, so from this actually gives us, I'll write this over here, x tangent of 25 equals 10. You got to divide both sides here by that tan of 25. So our answer here is going to be what we get from dividing 10 by the tangent of 25. Let's hit it. So we have 10. Let's clear all this out. 10 divided by our tangent of 25. Once we hit enter, we get 21.4. And when we round that, 21.4 would be just right for us. So here we are. X is 21.4. Boom. All right. So top part, that was the we do it. Let's check the I do it. I'll give you guys a couple of seconds to work it. Pause the video. Try them out. Welcome back. Hopefully you paused it. Hopefully you didn't just wait for me to come back into it. If you did, it is what it is. So for C, we got our adjacent side and our hypotenuse. Adjacent and hypotenuse, that means we're working with cosine. So we got the cosine of our angle, which is 56, equals our adjacent side, x over 14, our hypotenuse. So we're going to cross multiply. We got 14 times cosine of x, 1 times x. So that means we're going to go through and set that up in our calculator. So in the calculator, we got 14 times the cosine of 56. I'll close my parenthesis, hit enter. This is the length of our adjacent side. We're going to round that to the tenths place, which will make this 7.8. Let's see if I'm right. 7.8. Killing them. Boom. All right, lastly, we got D. D has 2 and X. 2 being our opposite, X being our hypotenuse. Opposite and hypotenuse means we're dealing with sine. So the sine of our angle, which is 31, equals 2 over X. So this situation for D is similar to what we had for B. That means that when we solve this, our X is going to be equal to what we get from dividing 2 by the sine of 31. So let's get that mathed out. All right, clearing it out. We got 2 divided by the sine of 31. Closing it up. Hit enter. That's our decimal. We round that up to the tenths place. This is going to be 3.9. All right. Now, folks, the last two here, these are going to be a part of your practice. So hopefully labeling the sides are giving you a little bit of an edge. So I will catch you later. See ya.